Hello everyone, welcome to this video. My name is Emerson Ahari. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how to calculate precipitation intensity index. So, this is very simple tutorial. Just for the first step, you must find a daily precipitation data. If you want to look into precipitation data, go to search places on dataset and then browse data catalog. After a few moments, in the new page, go to Browse by Tags and search your data based on desired keyword. For example, I'm going to find precipitation data. Then precipitation is the target tag here. As you can see, 41 dataset is available. Some of them are direct estimations or direct observations from satellites, such as GPM, and the rest of them might be actually assimilated products combined from models, satellite observations, and synoptic stations here. So, as you can see, one of the most well-known products for precipitation is Persian CDR. As you can see, this is one of the assimilated models that estimates precipitation based on the artificial neural network. Go to the dataset to get more information about the data characteristic. As you can see, this data is available since 1983 to 2024, the time I'm producing this tutorial. And also here, in the bands, you can see the spatial resolution is 27 kilometer. That is typical resolution for the climatological data. So, and there is a band allows us to get precipitation value based on millimeter and also provides daily precipitation value in our analysis. So, and in this tutorial, I'm going to show you how to calculate simple precipitation intensity index according to climatedex.org. This is a useful website for everyone who wants to study about climate extreme indices. So, here, to calculate the intensity index, we need the daily precipitation data to calculate the number of wet days based on PR greater than 1 millimeter per day, and also calculate the total precipitation for those pixels experienced 1 millimeter per day, actually, for each day separately. Back to the code in the code editor and try to call the Persian dataset. Copy the dataset title and back to the code editor, paste it in the tab here, and here you can import it as a single image collection. No need to select a specific location in this tutorial because I'm going to show you how to calculate intensity index for the whole of the world. Just make a variable as PR equals to the image collection including Persian data. Then filter your data based on a period of time you want to calculate the intensity index. For example, my date, start date, for example, the period I'm going to study starts from 2023 and ends to 2024. So here, print PR in the right panel, you will have 365 elements, all of them showing daily precipitation value for the whole of the world with 27 kilometer as a spatial resolution. So now if you look at the index here, you can see two variables is necessary. The first is the number of the days in which actually the precipitation was greater than 1 millimeter. Back to the code, we can make a function as, for example, we can make a function to calculate this variable. The variable is W, the number of days, the number of wet days, number of the days in which daily precipitation was greater than 1 millimeter. So here, call PR data first and then make a loop structure to detect all pixels or separate all pixels in different dates in their precipitation was greater than 1 millimeter. We need a function inside the loop to pass all existing images. Each input image considered as an IMG, or you can pick any other names. So the function returning the input image, the function actually returning the input image based on a threshold. For each date, select pixels greater than equal GTE, greater than equal 1. Here we are making a binary image in which the pixels with more than 1 millimeter precipitation returned as 1 and the rest of the pixels returned as 0. So we are repeating this calculation through the map for all of the PR data for 365 elements. Finally, if we get the sum of the 0 and 1 at the end, using the sum, we will have an image that shows the number of frequency of wet days for each pixel separately. So, through the map.add layer, here you can see the W image, that is the number of wet days. No need to click based on the region of interest because we want to do this tutorial globally. And you can use this tutorial for your region of interest, and you can use this technique for all daily precipitation data that is available in the Earth Engine data catalog. Although various datasets are available there, I prefer to work with the Persian product, but you may want to use any other daily precipitation data that is still okay, and there is no force to use this technique only using Persian model. You are free to use any other daily precipitation data you desire. So here the layer name is wet days, the number of wet days in 2023, and use the false at the end to avoid automatic visualization that highly speed up processing in the Earth Engine platform. Remember to save your code and run it again. After a few moments, go to the layer and check on the wet days. Here, as you can see, the wet days is a grayscale images that shows the frequency of wet days for different pixels. There are some noises as minus value that you can ignore them for the analysis. For example, here you can see the 90% of values actually ranges from 34 to 313. Or you can use the 98% of values in which the minimum is 6.9, meaning that only a few number of pixels might be noisy in our images, but 90% of values are correct, and you can see the values here. In the output grayscale, you can see here the brighter pixels shows higher frequency, and also the darker pixels shows the lower frequency. For example, if you increase the opacity or data opacity here, or decrease the data opacity here, you can see that the regions near to equatorial region actually provided higher wet days compared to the dry areas. Here you can see the regions with higher wet days and the region with lower wet days. And wet days here defined based on precipitation greater than 1. If you go to the inspector and click on a pixel, you can see the number of wet days for each pixel. For example, in this region near to equatorial line, here you can see 278 days actually we had precipitation more than 1 millimeter. But for example, one location in Iran only 70 days experienced their precipitation. That is the difference. So now in the next is the first parameter calculated. Back to the equation here. W is calculated. And now for the pixels in which precipitation was greater than 1 millimeter, we want to calculate the sum of the precipitation. That is RR, the second variable. So here, another variable should be RR equals to, so now get precipitation data first and make a function, each input image considered as an IMG here. And first we must make a threshold to separate wet pixels from the dry pixels. From each input image greater than equals, select pixels as wet with more than 1 millimeter precipitation data, and then we must return each image that is only included update mask, that is only included the regions with precipitation greater than 1 millimeter. So here the pixels in which precipitation is not greater than 1 millimeter will be removed. So finally, I'm gonna get the sum of the precipitation for the wet pixels. This is very easy techniques. So in this scenario, the total precipitation for dry pixels just and not considered for the calculation. So you can visualize the result through the map.add layer. So the RR is the target variable for the visualization, and here we will have sum of the precipitation that is false, and to avoid automatic visualization, again, automatic visualization to speed up processing in the Earth engine. Remember to save your code, and after a few moments, you will have some of the precipitation values only for wet pixels here. You can see just increase the contrast by 98% of values. As you can see, it ranges from 100 to around 5,000 millimeter per day. This is the total precipitation pixels experienced during a year. Unfortunately, some pixels suffered from some noises here that you can see, and only occurred for 2023. Maybe if you change the input year or input period of time, actually the uncertainties or noises will be removed. So here you can see this is the number of the total precipitation that is calculated for different pixels. And if you select a pixel through the inspector, here you can see the number of wet days and also the total of precipitation for the wet days that is calculated. So now you can calculate the intensity using two variables. We have number of wet days and we have total precipitation value. So the intensity will be equal to get the total precipitation divided to the number of wet days, same as what we have in the SDII, Simple Precipitation Intensity Index. So now you can remove its name as intensity, PR intensity here, and use map.add layer to visualize the intensity layer. No need to clip, leave the visualization parameter empty, or you can actually make a visualization like, for example, you can define a palette for a better discrimination of the regions with higher and lower intensity regarding to amount of precipitation they experience. So the palette including, for example, red, white, and blue. This color palette is one of the popular palettes that most of the times users use for climatological data, precipitation, or even temperature data in the environmental or climatological studies. So, and the layer name will be here the intensity or PR intensity. No matter what the name you are using, you can choose any other name you want and use the false at the end. So run a code, and since there is a problem here, go to the console, and here you can see, yeah, the intensity, the names are different. Intensity, just copy and paste it. Intensity, just like that. Run again. After a few moments, go to the layers. PR precipitation intensity is available here. Check it on, and after a few moments, you can increase the contrast by 98% of values in the image and click on apply. If you want to increase the contrast, you can use actually some exaggerated methods, and the red pixels shows the lower intensity and blue pixels shows the higher intensity. You can use the other exaggeration method for the visualization. Yes, there is. The blue regions experience precipitation with higher intensity, and the red regions experience the lower intensity. Or you can increase the opacity to see the background here. For example, if I add a value as 0.5, it reduces the data opacity, and it is a helpful technique to see the background to compare different countries and regions. For example, I'm trying to increase the contrast here. Yes, there is. For example, as you can see here, some regions experience higher intensity. For example, in the Europe we have higher intensity, but in the northern Africa, in Iran, Middle East, and also Central Asia, as you can see, we have lower precipitation and also the lower intensity. And you can easily export this image using export.image to drive. This is a very simple technique to get the export from the results you calculating in the Earth Engine. Actually, the Earth Engine now is a very, very popular tool, specifically for climatological data analysis, because there are tens, actually, data set regarding to the climatology. You can call every one of them here and calculate different indices that could be useful in your studies that you are doing. So the first argument is the image you want to get export. This is the intensity image. No need to clip it, or if you want to clip it, this is very simple technique. You can clip it based on a simple region. If you go to my YouTube channel, definitely you will find a lot of basic and advanced tutorial that allows you to know how to clip the images, how to get export, and so on. So, and the description refers to the name of the output is, for example, PR intensity here. The scale for the output should be 27,000 meter because the spatial resolution is 27 kilometer. And also the CRS coordinate system for the output should be EPSG4326. This is a unique code we use actually for WGS84 that can be used for all around the world. And the region of interest, you can ignore the region of interest no matter. But if you want to select a region, it is very simple. For example, you can draw a rectangle just like that for the whole of the Africa. I'm gonna get export just like that. For the Africa, for example, Africa continent selected, the region equals to geometry. It is totally optional, and this is the scale region, and you can make a folder in your Google Drive to save your data in. For example, I'm gonna make a folder as test, automatically created, and then output will be saved there. And the rest of parameter, no need and not necessary now. You can save the code and run it again. After a few moments, when the code is run, you can go to the task here, switch to the task, and PR intensity is ready to save. click on run, and after a few moments the process of running started. And here you can see it is started to run, and after a few seconds or after a few moments you can go to the address and pick the output and open it up into the QGIS, and all geospatial software you are using, no matter you are working with the QGIS or ArcGIS Pro or NV AirDAS, you can, as long as you are working with geospatial softwares, all of them can call or import the geotiff layers. So, and also this tutorial actually, as you can see, very simple and easy to use for intensity calculations. Now at the end, I'm going to show you how to make a function that easily do all of these process for any year that you want to study. So here, let me back to the code here and then make a function. Now pay attention here. I'm gonna actually make a function comprises all of these steps one by one, and you can use it easily for any year that you want. Here we can make a function like this. The function name is PR intensity. For example, PR intensity. The PR intensity including some arguments. The first argument is one input image collection, and the next argument is the date or year you want to calculate intensity for. And no need the other parameters. Another important parameter could be a threshold, because these are the dynamic arguments that can be changed from one study to another study. Here we did calculation based on 1 millimeter threshold, but maybe you want to change it to 4.5 or higher or lower values regarding to the region of interest you are working. But in the global scale, the 1 millimeter per day is the constant threshold, but you can change it regarding to the location you are working. So now these are the input arguments that you can change them from one location to another location. Then we can actually add this parameter exactly one by one into the body structure. Here, for example, I'm gonna filter the data first. The input collection should be filtered based on a period of time that is already defined by the date or year. We can actually make a variable as year equals to Earth engine that date allows us to convert the date value to the date format. So now the filter dates including two variables. The start will be the year and the end. For example, I'm gonna calculate it for only 1 year. If you want to do it, just call the year again and go advance or go forward until the next year. 1 year. There it is. And skip the time zone. So now after your data filtered based on the target year, and then you must calculate the number of wet days and also the sum of the precipitation. This is very easy process to do. You can copy and paste it into the existing function. The number of wet days equals to, now the target image for calculation is the filter, the image that is already filtered inside the function structure. All the variables we are using, variables or arguments or parameters we are using in the function should be already defined by the argument or the previous variables we have in the previous lines. So the filter collection imported here, and then all the images imported into the loop structure, and pixels with precipitation greater than 1 millimeter selected. After the number of wet days calculated, now we can do the process where we can calculate the number of the total precipitation value, using the RR variable, or we can name it as total PR or PR total, no matter which kind of name you are using. Instead of the PR, as I mentioned earlier, the input will be filtered, and now for the target year or the desired year, we want to make a function and also make a mask layer based on the threshold we already defined here in the arguments. We want to update mask based on images dot greater equal GTE 1 millimeter, and then their sum value or the total value will be calculated. So there it is, and finally the intensity will be calculated like that with different inputs. The intensity should be indexed here. Instead of RR, we will have the precipitation total, and that's divide number of wet days, and PR intensity now calculated. Finally, the function returning the index, as you can see here, and now the function is ready, and we can apply it for any year that you want to use. For example, I'm gonna calculate the intensity for 2010, for example. PR or SDII was the official name for the index, SDII or intensity index for 2010, for example, equals to, the function name was PR intensity. The input arguments, instead of image collection, you can enter the image collection. The year we want to calculate is 2010. I'm gonna calculate the intensity, precipitation intensity index for 2010, and the threshold will be 1 millimeter. So now let me actually to run a code, make a print that rename, or you can rename it based on the date. That rename as like this. Rename the output as PR intensity plus the date. Print SDII 2010 and run a code. In the right panel, we have an image that shows PR intensity for 2010. And now you can add the visualization process as an inside part of the function, and no need to write map.addLayer or export.image anymore. Just here, map.addLayer could be added just like that. After index calculated here, we can yes, PR intensity plus date should be added in the before variable here, plus date, and get rid of or skip the rename process at the end. Finally, I'm gonna visualize the index with this color, palette color, and the name in the layer setting. I'm gonna actually show the year or the target year next to the other parameters here. There it is. And now run a code. Remember to save it and skip the geometry import. Here you can see the PR intensity for 2010 is also available. You can actually visualize it using 90% or any other stretching techniques that you want to use here. Click on run, and here you can see the different region with different intensity values. Everything already settled up in the everything already prepared in the function structure. And as you can see, it is very easy technique to use this function for different years. For example, I'm gonna calculate it for 2015. Just the year or input year changes. And also we can add export.image to drive here to get export automatically. And the target image will be the index, the PR intensity, plus the date to separate different exports for each year with 27 kilometer. You can define any other regions or a target regions, no matter, and it will be saved in the test. Save your code and run it again. After a few moments, you can see, if you go to the task here, you can see the PR intensity for 2010 and 15 is available. Just click in run and wait until the process of saving completed. Once the tab's color turns to the blue, meaning that the process is completed, and you can pick it up from the Google Drive and open it up in your geospatial software. I hope you like this tutorial and suggesting you to use the code available below the video in description box that will be helpful for you to understand and find the issues and syntaxes errors if you have in your code. And if problems still exist, feel free to reach me out on my YouTube channel, and asking you to like this tutorial and share it with other remote sensing users or earth science users in all around the world. Thank you for your attention.